Hello, Professor Seager. Welcome to Open's interview series, Women in Sci-Tech. I'm George Newman, founder of One Planet Education Network. Today, we're honored to have Professor Sara Seager, a world-renowned expert in the search for life beyond Earth. Professor Seager has agreed to join Open for the second time in recent history to discuss her incredibly exciting and potentially civilization-changing work. Dr. Seager is a professor of physics and planetary sciences at MIT and is doing groundbreaking research with advanced space telescopes, future planetary probes and technologies in the hunt for other Earths and extraterrestrial life. Dr. Seager is a frequent guest expert appearing on many science programs, including NOVA, National Geographic, and now here on our Open interview series, Women in Sci-Tech. This interview will be co-hosted by Open's Ashley Ruiz and Syra Mehdi. First off, Open sends out a special thanks to Crystal Whalen for arranging the interview, and of course to Professor Seager, who today will update our students worldwide on this truly important field of research. Welcome, Professor Seager.
Thank you. Hi.
Hi, good to see you again. And welcome, of course, Ashley and Syra. Professor Seager, because some of our audience are new to exoplanets and your work in your field of research, if you could just give some basic background on the field and your profession, but also your work as well.
My field is researching exoplanets, planets that orbit stars other than the sun. And if you look at the night sky image behind me, you can see so many stars. Well, each one of those stars is a sun. And just like our sun has planets, Mercury, Venus, Earth, Mars, etc., the other stars, it makes sense of their suns that they have planets also. And they do. And we astronomers have found thousands of planets. And there's probably one planetary system for every star. There's probably a planetary system for every star. And there are probably trillions and trillions of planets in our galaxy alone.
Wow, yes. And before this in 1995, I think it was, when they found the first real evidence. I mean, it was always, figured that might be the case, but our instruments weren't, yet refined enough. And they happened upon the first star with a planet in around 1995, I think it was. And then since then, the world has really changed with more technologies in your field and led us to this, reality that we are.
Right. Well, people have literally for thousands of years have wondered about the night sky and stars and even planets around those stars. And exoplanets have been sought for in earnest for over, I want to say, about half a century. And people thought they found some and then they didn't. A lot of false evidence. And then, yes, it's true that in the mid-1990s, the first announcements of planets orbiting sun-like stars were made. And it's for the same reason as, technology all around us. Think about your phone today compared to your phone. Maybe I don't know if you had a phone in 1995. Some of our listeners won't even have been born then. But, everything is getting better and better, and people push to make their instruments more and more precise.
So with all these planets out there, where do we begin our search? And I know you've been doing a lot of research, and you tipped us off to what was coming. I think it was 2016, and Ashley's going to get more probe this a little bit further. But there's even a close, the closest triple star system to us, which is the Alpha Centauri system. They found a planet orbiting one of them.
Right. But I want to just answer your question directly for a moment, because the question is, where do you begin?
Yeah.
Imagine you're looking for an underground ant colony, the biggest one you can find. Are you going to trek into the middle of a forest and camp and continue hiking up a mountain? Or are you going to look in the easiest way possible? Sometimes on the sidewalk, you see a giant number of ants swarming, and then you can go back and see where they live. So right now we're kind of still doing this. We're getting a bit better, but we're looking at the most easy targets,
Mm-hmm.
We're not necessarily looking for what we really want to find at the end of the day. We're doing the easier things first. But as George, you pointed out, as our technology gets better and better, we can find, in this case, smaller and smaller planets. And what you just were mentioning about our nearest star, Proxima Centauri, it's just phenomenal that there's a planet about the mass of Earth around our very nearest star.
That was a nice surprise. And
Like, it
so,
is a surprise. The funny thing is it's a surprise, but then, if we could think about it, maybe it's not in a way, right?
Yeah.
Because we expect planets are, we have evidence that planets are everywhere. And so, yeah, it's kind of a surprise, but perhaps kind of not in a way.
yeah, exactly. And there's probably been some follow-up since it was first discovered. But is there any thoughts about its habitability in recent days that I'm not familiar with that you might be?
Well, there's one thing that's pretty much of interest, and that is they've been monitoring the star, and the star has flares. Our sun has flares as well. It's energy that comes off the star. But this particular star has a lot of flares, and people have been monitoring it to just kind of see what it's been up to. So I don't think we knew that. I don't think it had been studied quite as much back then, but the stars like Proxima Centauri, they're small red dwarf stars, much smaller and cooler than our sun. And they also are what we call more active. The star, it's kind of a weird way to say it, but it's badly behaved. They give off flares of high energy particles. And this particular star has a lot of flares, high energetic flares that hit any planet orbiting that star.
And the planets, in order to be considered in the habitable zone, which where liquid water might exist on it, where we know that life might have emerged on Earth, that doesn't bode well with flares, that close to the star, I guess, right?
Can you repeat that, please?
Well, no, I was just saying that the star is, the planets are close, and if it flares and, it's got potential habitability because it's within the habitable zone where liquid water might exist on the surface, it would kind of fry things with those big solar flares.
Like yes and no. But the thing I was trying to remember to share with you is about a month ago, Proxima Centauri had a super flare, and astronomers managed to catch it by lots of different telescopes all around our planet, or around our own planet. The thing is, I used to think these flares were so, okay, I'm going to give you a bit of an analogy right now. So here in the Northeast, where some of us live, we have big snowstorms. Like you can get, 2 or 3 feet of snow in a matter of like 8 hours. And when that happens, we're told to stay off the roads, stay inside. Sometimes they even close the roads. That means you'd get a ticket. You'd be like, I don't know if illegal is the right word, but legal to drive. And so, they shut schools and businesses, and we have to stay indoors. I mean, you don't have to stay indoors. You can go out, but at your own risk. I imagine if there were life, intelligent life on a planet with a star that super flares, it might be similar.
Yeah.
You might say, okay, we have a prediction now. You know what? Tomorrow there's no school, no work. Everyone, not just stay inside, stay in your basement, in your specially constructed room to prevent high energy particles from hitting your body and giving you cancer. We had a super flare here on our Earth in the late 1850s. It was called the Carrington event. And it was pretty remarkable because the flare hit our planet and it created northern lights almost all the way down to the equator. And here in Boston, we'd be able to go outside and read a book at nighttime by the northern lights. Telegraph wires caught fire. It was quite dramatic, apparently. However, nobody died, no one really. So the flares sound really scary. And I think it might change how life has to kind of navigate. But in the end of the day, I don't think it's going to be super destructive.
Oh, that's good news. The other star types that I'm very interested in, because it's sort of in between the red dwarf, close proximity planets for habitability, and our own yellow or star, class star, is a K orange class star. Am I correct in that?
Right, orange, yeah.
Yeah. And one of them is, I think one of the Alpha Centauri stars is a K class. Are there any of those? What are your thoughts on K class stars for potential habitability?
Well, we think that planets can pretty much be habitable about any star type.
Yeah.
It probably doesn't really matter what type of star it is. When we think about what life needs, it's a source of energy. So that could be any kind of star. And some life gets energy even without a star. using chemical potential energy gradients in the environment. It needs energy, it needs the life needs a liquid. Water's obviously a good one for our life, some kind of liquid so that chemical reactions can happen. Life needs the right temperature. If it's too hot, we can't have complex molecules. And some people add a fourth one, that life needs changing conditions that force it to evolve and become something. So in that sense, it really doesn't matter what type of star. We actually like Kstars because they're smaller than our sun slightly. And it just makes detecting a planet easier because the planet's always hidden in the glare. You can't usually see the planet on its own. You often only see an indirect effect because the planet and star are so close together and the star just dominates. So the smaller the star, the easier our job is. And so that's kind of why K-stars are a bit more favorable than sun-like stars.
Excellent, excellent. So I'm going to hand it over at this point to Ashley. And thank you for answering the basic questions that I had. Thanks very much.
Hi, Professor Seager. It's so nice to chat with you again. So much has happened in your field of planetary science and new technologies for scanning the cosmos for life since the last time we spoke. That's both within our own solar system and those many other solar systems beyond that, that are also likely to host at least one planet. Can you first give us a quick rundown on what has happened since we last spoke in 2016? Just some of the highlights from your perspective in the search for life beyond Earth in science research in general?
Right, okay, let me think about that for a second, because there's so much has happened. I can just start with one thing that happened that was a big thing in exoplanets, and that was in April 2001. In April 2018, NASA launched its second exoplanet mission called TESS, Transiting Exoplanet Survey Satellite. And I actually just recently stepped down from a leadership role on that mission because it was conceived of and implemented, and it's run out of MIT. And it was exciting. We got to go down to the launch, the rocket launch. That was kind of, obviously pre-COVID, we were traveling, and it just got delayed. The launch got delayed just enough so it landed right in spring break. So myself and others, we could take our kids and go down for the week. And the launch was just absolutely beautiful. And TESS launched, and it's been finding lots of planets. It was actually my job to formulate the team and organize the team that helped find planet candidates. Where TESS stares at one giant strip of the sky for 1 month and searches for transits, planets that go in front of the star just fortuitously with the right type of orbit, and the stars drop in brightness by a tiny amount. And it's kind of like a giant effort to identify these planet candidates, and then for others, hundreds of astronomers around the globe, to help follow up these candidates to see if they are planets or if they're a false positive or something else. So TESS has found many planets, actually. It's found tons. It's found well over 1,000 planet candidates. And the sort of number of confirmed planets is somewhere under 100, but growing.
Wow. In only 2 or 3 years. That's amazing. Yeah.
There's another planet that's really interesting too. NASA's first mission, Kepler, was running in its second phase, which was called K2. And K2 found a lot of special planets as well. One of my favorites is called K2-18b. They have kind of these awkward names because they're just named after the mission. The star doesn't have a name because it's too faint. No one really cared about it before. But K2-18b is a really interesting exoplanet. It's orbiting a red dwarf star, and its orbit is about a month. But because these red dwarf stars give out a lot less energy than our sun, 1 month orbit, and from Kepler's third law, the closer, the time it takes to go around the star is related to the distance. But anyway, this planet is actually in the habitable zone of its host star. Now, K2-18b, it's not going to host life. It's a mini Neptune, not a rocky world like our Earth. So it doesn't have a solid surface. It's not suitable for life. But nonetheless, it's been a really exciting find because planets like K2-18b we call them mini Neptunes. They're 2 to 3 times the size of Earth. We have nothing like that in our solar system. Yet, out to about 100-day period orbits, these things appear to be the most common planet in our galaxy. And K2-18b was one of the first kind of mini Neptunes orbiting a bright red dwarf star. And TESS has found many, many more. And it's just exciting to have a whole population of these around nearby stars because we hope to follow up their atmospheres. And indeed, people in this time since I last spoke to you followed up the K2-18b atmosphere, found some water vapor in the atmosphere, found some other stuff. And so this whole sort of birth of these sub-Neptunes that are around stars bright enough for us to eventually characterize the atmospheres, that too is like a big thing.
Wow. So what might be the most exciting or promising findings for follow-up observations with like the James Webb or its successors?
So another thing that happened was the James Webb Space Telescope, which sometimes people call our next Hubble, although it's quite different. It's bigger, it's infrared, it'll be orbiting far away. The James Webb Space Telescope is set to launch in October 2021, October of this year. So the James Webb Space Telescope organizers, they had a competition round. And so you could write a proposal and compete to get telescope time. So the program for the first couple of years for exoplanets is all mapped out now. And there's lots of interesting things will be observed actually. These mini Neptunes, there'll be some small rocky worlds. There are a very special system called the TRAPPIST-1 system with 7 rocky worlds. Each one of those, I think everyone has observations planned for it. There's a lot of mysteries in exoplanets now that we're hoping the atmospheres can help solve.
And I think, Syra, I think you're up next and with your series of questions, if you want to. Thank you, Ashley.
Great.
Thank you.
Yeah, it's really nice to meet you, Professor. So turning the subject back to our own solar system, regarding your team's research on phosphine in the atmosphere of Venus as possible indicators of microbial life there, what are the latest findings telling us from your team on that surprise and intriguing finding?
Wow, what a great question. So I was part of a team that made this big announcement last September 2020, of the discovery of phosphine on Venus. And why this is so exciting and astonishing really is there shouldn't be any phosphine on Venus.
Mm-hmm.
Just like on Earth, Venus has almost no hydrogen.
Right.
Phosphine is 1 phosphorus atom with 3 hydrogen atoms. There's really no reason for it to be there. And at the time we said, we've worked through all possible known chemistry, lightning, volcanoes, meteorites, delivering material. And nothing that we worked on could produce phosphine. So it could produce some phosphine, but way too small amounts of phosphine.
Mm-hmm.
Now, when we made that announcement, soon after, it became very controversial.
Mm-hmm.
Chemists attacked it. People looked at our data because the data is public, and some of them didn't find the phosphine signal.
Mm-hmm. And
so it's been like a giant kind of controversy, and it's really ruffled feathers. That's a polite way of saying like people got angry about this. And in fact, just today I was helping edit a response. It's actually like a full-time job for our team leader, Professor Jane Greaves, to write papers that respond to the criticisms. So people write a journal article and they submit it and it's saying, we don't find phosphine. Some of them say, we do find a signal, but it's not phosphine, it's sulfur dioxide. So we're kind of constantly weighing back in and explaining our method of data analysis and why we find a different result from other people.
Got it.
But the reason why I like the question is that's how science works, how it should work.
Yeah.
You find something, you put it out there, there's data, and other teams can work on the data, can think of other hypotheses, and it kind of just goes from there. So to make a long answer short, it'll be a while before it's resolved.
Got it. Yeah, that makes sense. And can you tell our younger audience about the planned follow-up robotic mission in the works to probe the part of Venus's atmosphere where phosphine is showing up?
Yes. Well, in part, just to segue, we really want to send a mission to Venus to go in the atmosphere to search not just for phosphine, but other signs of life and perhaps even life itself. Now, you should know there have been, I think it's like 36 missions that have either flown by Venus, orbited Venus, or dropped into the Venus atmosphere. But it's been over 40 years, 4 decades since the Americans or the Russians have sent a probe into the atmosphere. So it feels like it's time to go back. And in fact, there's been a competition for a NASA mission, a class called Discovery class mission. And there's 4 missions now, 4 missions at the moment competing. 2 of them are about Venus, and they might select 2 out of 4. One's a Venus orbiter, one's an orbiter plus a probe. So there's some chance that will get selected. Like on my own, and you've really clearly done your homework. I've been leading a mission concept study. And our mission concept study is privately funded, so we don't have to, that means just we can do what we want, we can focus. And our mission we have several ideas. It's kind of all still churning through. We haven't settled on one thing or the other. We have a lot of mission options we think that would get the job done. One of the options, our first one, is that Rocket Lab, a private commercial spaceflight company out of the USA and New Zealand, led by Peter Beck, they're committed to sending a small rocket to Venus, launching in May 2023. And we are part of their team. We're the science team, and we're helping select there's only room for one small instrument. It's a very small rocket, so it'll fly by Venus, drop off a probe. And this probe it might take about an hour to reach the surface, but that area in the clouds where phosphine is, it's only going to spend 3 minutes there.
Wow. That's incredible.
Yeah, we're going to have an instrument that's going to go there, and we're still kind of deciding which instrument, but it's been a very exciting journey, actually.
Yeah, it sounds exciting for sure. And regarding the recent Mars landing of Perseverance, are you and any of your colleagues at MIT involved in that exciting mission to find fossils of past microbial life?
We're not involved in that mission. I think one of our team members has a role on that mission. We're not involved, but we're paying very close attention to it because that mission carries some instrumentation that we've been considering for our concept study for a balloon-borne mission. So we're thinking of how those instruments work and how we would adapt them to work on Venus.
Right, that makes sense. And then lastly, what are your thoughts on the closer look for life beyond Earth that the robotic missions within our solar system to Europa, for example, and I'm not sure if I'm pronouncing that right, found where there was a subsurface warm ocean full of life?
Yes, well, they found the subsurface of warm ocean that they don't know has life, but we hope it does, of course. I think it's remarkable just how we have just opened our minds and thought about all the different possible environments where life could live based on what we talked about earlier, energy source, liquid, right temperature, and hopefully changing conditions. So I think they're all wonderful places. If we had enough money, we should go to all of them.
Yep, absolutely. And I'll throw it back to Ashley again.
And how about any other cool research that the public doesn't know much about?
Okay, let me think about that for a second. Well, okay, so there's a sort of bigger thing. I'm going to try to encapsulate it very briefly because research, it's a good question because research is always ongoing. And it's kind of like when you hear about a science result, someone has like phosphine. That was 5 years in the making. And there's always stuff going on behind the scenes. So, my favorite work is on the search for signs of life. And we work on these sophisticated computer models to understand what kind of gases might signify life. Like here on Earth, oxygen, we all need to breathe oxygen. It fills our atmosphere to 20% by volume. And that oxygen is created by plants and by photosynthetic bacteria, without which we'd have virtually no oxygen in our atmosphere. But our own Earth, we only had oxygen for the last billion years. Seems like a long time, but for our planet having been around 4.5 billion years, it's not that long. Yes, we're just working on all the different gases that might be possibly to be signs of life. But what's new is we have kind of run into a bit of a dead end here, a problem. This problem is amplified by phosphine. So some people, we found phosphine, we can't explain it by any other chemistry. There's just some outside chance that, wow, it'd be amazing if it was made by life. But what we found was that people don't believe the signal. If people recover the signal on their own, they don't want to ascribe it. They don't want to identify it with phosphine. They want to say it's sulfur dioxide. So now I want you to imagine an exoplanet orbiting a star, a distant star. And we'll use the James Webb Space Telescope or another telescope, and maybe we'll find phosphine. Maybe we'll find another gas. We have a long list of gases. But will we? I mean, you could all be coming back and interviewing me or interviewing other people. And what will we say? You'll say, oh, how do you know? You'll say, oh, are you sure? And the answer will be, we're not sure. And if we don't believe Phosphine on our planet right next door, where we've had nearly 3 dozen spacecraft fly by, orbit, or land, or visit, like it's a much more complicated problem. So I've started to have like a mini crisis. And I don't think it's just me, but others. And so, we have to think about how we're going to work on this problem. And I mean, the answer is always, it's sort of circling back to where we started, better instrumentation. And it's going to be a generations long endeavor, basically. And I could, if you are curious, I could tell you about some of the things people are thinking, but now we have to stretch our minds even more and think about like the next generation.
I would love that.
Sure. Okay. Well, there's 2. So part of this call, it's to inspire people. Like, always spend part of your time like dreaming of something big, like for yourself personally, for yourself professionally. It's so important to use the creative gift that we all have within us. And these 2 ideas aren't mine. I just am a champion of them. One of them is called Starshot. And Starshot is a plan to figure out how to send spacecraft, tiny, tiny spacecraft, and thousands of them, to fly by the nearest star system and snap images of a planet and send those images back to Earth. And what Starshot is, it would be thousands of little tiny space chips, little chips that would deploy like in outer space above Earth, and they would deploy a solar sail that's a few meters in diameter. And the vision is to have a bank of lasers on Earth that can output like a gigawatt power. That's a lot of power. And they would shine a laser on these sails, and using something called radiation pressure, accelerate these little space chips, they call them, and thousands of them will get accelerated to about 20% the speed of light. Now, they would take 20 years to get from here to the nearest star system, and then they would take a few years to send information back. But we have to kind of start thinking ahead. Like, imagine a world where our projects, it's going to take like 20 years to get it to work, and then 20 years to launch it. And then 20 years to get it traveling. So that's a lot of years. The other idea is equally ambitious, and it is to send a space telescope far away to about 500 times the Earth-Sun distance. That's further than we've sent anything before. And what this telescope would be able to do is it would use our sun as a magnifying glass, as a gravitational lens. Because mass bends space. And I don't know if anyone's familiar with the story about Sir Arthur Eddington and the famous solar eclipse that I think was in 1919. Well, Einstein predicted general relativity meant that mass bends space. That means our sun is bending space around it. And what Einstein said was that if you could look at the stars, like see behind me, and then if you could look at the stars when the sun was there, the stars would be in a slightly different place because their light was going to get bent around our sun. And you have to kind of draw this all out on the blackboard or on paper. The position of the star looks different because the light rays got bent and it got kind of messed up. Well, we can't see stars during the day, right, because of the sun. But during a solar eclipse, I hope you can all see the next one. It's in April 2024, okay? You can see stars during the solar eclipse. So Einstein made this prediction, and Sir Arthur Eddington went out and he measured the stars were in a different place right near the sun when the sun was blocked off. It's phenomenal. And that's why Einstein became instantly famous, because this crazy prediction he made was correct. Well, if we can put a telescope at 500 astronomical units, we can use our sun to bend space. And it not only changes the position of things, but it magnifies them. So imagine if you knew of a planet and you could line up your spacecraft and the sun in between. That sun literally would act like a magnifying glass because it bends space and it magnifies what's behind it. And then we could image a planet to 10-kilometer scale resolution.
Oh.
Yeah, but there's always a but, right? Okay, so this spacecraft, we don't know how to do this problem yet because we have to, it's going to, and once we know how to do it, it will still take 20 years for the telescope to get from here to there. So it's still a very kind of long story, but yes. So what's new is that it might not be new to everyone, but it's new to me kind of, is the realization that it's going to be tricky to identify signs of life on an exoplanet by way of gases that don't belong. So while we're doing that, we still have to think ahead and invest in the next steps, which will be for you. I mean, any budding astronomers listening in, that's your generation who will get to see the fruits of those investments.
That's amazing. So do you have any upcoming Earth 2 hunting space or ground-based observation platforms, starting with the James Webb Space Telescope later this year?
Can you ask that question again, please?
Oh, do you have any upcoming Earth 2 hunting space or ground-based observation platforms, starting with the James Webb Space Telescope?
Yeah, so one thing about James Webb is it won't actually quite be able to find an Earth twin. It can only study Earths around small red dwarf stars because our sun, an Earth sun twin is just not favorable. The sun is just too big. But there is this new telescope I'm going to tell you about. I'm not involved with this right now, but it's called the Terra Hunting Experiment. And this is a new telescope. I think it's not quite online yet, but its goal is to try to find another Earth. And it uses this method called radial velocity, where the star wobbles due to the planet orbiting it, due to the planet's gravity. And so this is something new that I thought I would just share with you.
Great. When is that predicted, if I may jump in?
Well, it's supposed to start online in early 2022. Things usually take longer than you expect, but I think it's like a state-of-the-art instrument on an automated telescope, and it's like a dedicated telescope. There are other things similar to that, but that one, it just has, I think it has a lot of promise.
Is that the observation technology or program that you're most excited about right now, or are there others?
Well, my heart is always with the Starshade. I think we probably talked about that last time. Yeah. The Starshade, it's a giant specially shaped screen, tens of meters in diameter, and it would fly in outer space. It would have its own spacecraft, and it would formation fly with a telescope. And together, they have to be tens of thousands of kilometers apart. And they line up perfectly, so the Starshade would block the starlight so we can see the planet directly. Now here in the USA, every 10 years, the astronomy community gets together. It's called the Decadal Survey. And this is very official, very formal. And everyone's voice is supposed to be heard. And there's a top level panel, which priority rank orders all the projects. And so I don't know if anything in your sphere is like this, but you have to get to the #1 spot basically in order to get funded. So Starshade remains my favorite project because Starshade would be able to block out the starlight and see planets directly, including another Earth. It would just be a point of light, like a pale blue dot, but we could look at the atmosphere and we could identify it as Earth-like. So I'm keeping my fingers crossed that Starshade either gets #1, or if it's not #1, it gets in a bullet point to get more funding.
Yeah.
And when is the next decadal survey?
Well, it's coming out anytime. That's the thing.
Okay.
Yeah, I forgot to say that. Thanks for asking that, because it's 2021 now, so it happens every decade, right at the turn of the decade. And literally, we're all waiting. We think the report will come out in June of 2021, or so. Yeah, it's coming right out.
Real soon. That would be wonderful. Great. Yeah, I wish you all the best for that, because that to me seems like a lot, even an easier technology than the 500 AUs out from the sun.
Well, sometimes it helps if I tell you about the 500 AU out one before I tell you about Starshade, because if I tell you about Starshade first, that sounds really hard.
Yeah.
But it's what is hard, what is easy, but it's what is complex and what is costly.
Yeah, right.
And we're still waiting to launch our James Webb Space Telescope, which was very expensive, very complex. And so, just sort of now switching to politics a bit, we're not sure I don't know what's going to go through the people on the survey's mind, but one of the thoughts is maybe we're not ready to do something big and expensive yet until the James Webb is safely launched and working.
Let's say that you were able to get sole use of the James Webb once it's up and working. Where would you point it and why?
Wow, I would like to spend a lot of time on each rocky exoplanet that is accessible to the James Webb. And they're not very many. There's maybe a dozen. Most of those are the TRAPPIST planets, because you still need a really bright star. The way we look at the atmospheres is when for transiting planets, they go in front of the star as seen from the telescope, and the starlight shines through the atmosphere. And part of the starlight doesn't make it through. And by comparing which wavelengths or colors of light make it through compared to which don't, it sounds pretty amazing, but we can identify what gases are doing the absorbing in the atmosphere. Not enough stars are bright enough to backlight their planet's atmospheres. So I would devote a lot of time to each of those rocky worlds. But then we kind of have a menu. It's almost like if you go to a restaurant and there's a menu, and in your mind, like some are to you sound better than others. But I would go through a lot of the other mysteries, like some of these mini Neptunes. Some stars have 2 or even 3 mini Neptunes in the same system. And we feel like if we could look at each of those in the same system, you know, you could if they're all the same or if they're different, it would give you a clue as to what they are and perhaps why they're there. So I'd sort of have a whole list of things I'd go through.
And I would think there could be exo-moons around those mini Neptunes potentially.
It would be amazing if there were, it would be awesome.
And do you see any likely successors? I know that you're still waiting for, you said in June for it to come out when they let you know what you can go ahead and work towards, but do you know any that are likely to get funded and maybe when they'll come online?
Well, there is one mission called Ariel, which is a European Space Agency mission. It's much smaller than the James Webb Space Telescope, but it will be dedicated 100% to exoplanet atmospheres. It won't be able to reach down to Earth's, so we'll be doing mostly larger planets, but it could really clean up, like it could really make great results in a lot of areas. So I think Ariel is supposed to come out towards the end of this decade. I'm not sure exactly when. So that's something that's concrete, that is funded, that will happen. We also have this other amazing thing in astronomy. They call them very large ground-based telescopes. So right now, our large telescopes, they're about 8 meters in diameter. The mirror is about 8 meters, which is big, actually. If you think about it as a person, you're probably 1.5 meters. So it's like if you lay down, that's like many of you all together would make up that mirror diameter. So if going from 8 meters or 10 meters, these new generation of telescopes, they are 20 meters, one is 30 meters, and one is almost 40 meters in diameter. And all of these telescopes are very big. They're on the ground. 2 of them are in Chile. One of them, we're still figuring out where it's going to go. We want it to go in Hawaii, but it might not be able to go there. And these large telescopes will open up a new window. And they also can play a role in exoplanets as well. So we have that to look forward to too.
Wow.
Well, thank you.
Amazing.
Sara.
So, and correct me on pronunciation for names, but Avi Loeb from Harvard thinks that Oumuamua, our first confirmed interstellar asteroid, is an alien probe, and he is sticking to his guns. But on the other hand, evidence is also showing that pan-stars can now find many others we were never able to see. So what is your take so far on this really fascinating and still seemingly so unique object of Oumuamua?
Right, well, let's talk about that because that's been a fascinating, not just scientific, but also sociological.
Yeah.
Wow, craziness. So just in the interest of full disclosure, when I was a graduate student at Harvard in the 1990s, Avi Loeb was there as a young professor. He had just started his job. And as I got older and grew up, I want to say I became friends with Avi, and he lives in the neighboring town. So just in the interest, I'm not here to defend him, but I peeled away the layers of the onion to get to the heart of what I thought it was. So now there've been a lot of dialogue and some bad things have happened, but what's very interesting is and I had the chance to ask him this question, and you'll find out that, I'm going to try to paraphrase here, he's not saying he's 100% sure this is an alien probe. What's really interesting is saying that what the data shows you in his mind, the data that's there, it's equally supportive of an alien probe as of anything else.
Mm.
So that you can have a crazy theory that it's an alien probe, or you can have a crazy theory that it is a ball of hydrogen, frozen hydrogen. You know, so like that's, I think as scientists, we have to kind of just think about that. That's like if I say, let's take at face value that the signal of phosphine is real.
Mm-hmm.
It could be some completely unknown chemistry that no one can figure out, or it could be life. And I hope you agree with me that both of those are preposterous, really. And so
Absolutely.
That's what Avi's trying to say. He's not trying to say, oh, it's an alien, blah, blah. Because this Oumuamua showed some really weird behavior. Like, first of all, it's a really strange shape, right? They think it's very flat compared to its length. And it went through our system and it got gravitationally moved its orbit by our sun. But there was something else, because its orbit doesn't just match the gravity from the sun. There had to be something else going on. And apparently comets, they heat up and they outgas. And so by losing some mass, their orbit changes. But people had been observing this object and they didn't see any outgassing. There are those two things. And there's one other thing, I forget what it was. There are these three very unusual pieces of evidence that don't match any explanation of any kind. So I think it's wonderful. Like, what do I think it's more likely? Something we haven't thought of, or an alien probe? I would say it's probably something we haven't thought of, but I don't know, like I don't have, I wouldn't say one thing or the other. And when I pressed Avi to say, which one does he think it is? He actually did say he would lean towards it being an alien artifact. So I'm not really sure, but I think it's such a great example for science of like, we have limited data. We have no explanation. So how do we move forward with this object? And what you said, pan-stars, it may be that just like when I said for an exoplanet atmosphere, we might find a gas, want to attribute to life, but not have enough info. So we might just have to say with Oumuamua, perhaps we've dead-ended. We're done. Okay, it's a problem. We're fighting. We're disagreeing. We're getting angry. But we got to wait for the next one now. And hopefully, as you said, we'll have more and we'll be ready.
Sure. Yeah.
Actually, you know what some people want to do? They want to put a spacecraft, like a satellite orbiting Earth, in such a way that it could zip over to catch up with an object and get close enough to learn more about it.
Wow, interesting.
Yeah.
It's hard to conceptualize that, but that's amazing.
So, it's just kind of like the exoplanet thing we were talking about. What's the next thing you have to think about? We're trying to think ahead to figure out how we could solve this debate for some new objects.
It'll be like a policeman hiding behind a road sign.
Yes.
When it goes by, it chases and pulls it over, right? It's
right.
Give it a ticket. That's fascinating. Wow.
So what are your thoughts about the breakthrough Starshot and, sending a fleet of tiny chip-sized robotic probes to the nearest star, Proxima Centauri, in one person's lifetime?
I think it's amazing. But what I love about this is that the inspiration value is huge, because it kind of shows us that anything is possible. And the money given by breakthrough initiatives to Starshot, it's not going to make Starshot happen. It's a lot of money, $100 million.
Right.
It's not enough to make it happen, but it's enough to buy down technology, enough to solve the big problems. So I love it because, in exoplanets, George was saying, well, before we didn't know of any. We not only didn't know of any exoplanets, but working in the field of exoplanets was considered bad. It was considered taboo, sketchy, like not good to get a job, actually, not good for a career. But in exoplanets, this line between what is considered crazy and fringe and what is mainstream, that line is constantly shifting. So today there's a few thousand people working on exoplanets, and it's certainly very mainstream. Now it's maybe in some ways easier to get a job if you work on exoplanets than another topic in astronomy. I mean, that's not totally true, but I'm just exaggerating to get the point across. And so just by putting money behind Starshot, breakthrough initiatives is shifting that line.
Right.
And
yeah.
So to see that value is really high.
Yeah, I would agree. That's very inspiring. So finally, what do you think about the square kilometer array for detecting other intelligent civilization signals?
So, I love how you've touched on so many different topics. And one thing I just want to add here is, in astronomy, it's sort of like we've done the easy stuff. In the old days, if you're someone who's gone to college or is going to college, your university probably has a telescope somewhere.
Right.
It could be on top of your building, or some of them, like where I work here at MIT, we have an observatory called the Wallace Observatory, which is in Groton. It's about 60 miles outside of Boston.
Yeah.
But those observatories, they're no longer good for research because our sky is so cloudy. They're not really big enough. Our scene is terrible, like our atmosphere is turbulent. And so now institutions that invest in astronomy have telescopes in Chile, like we have a share of a telescope in Chile, and it's getting harder and harder. So now for radio astronomy, when it started, people would just build an antenna and put it outside. And now we're trying to get this like literally a square kilometer of arrays of different. So to me, I always like, when I hear the word square kilometer, it's like, whoa, why do we need that? So, because we're trying to like go to the next thing. I don't know. I love SETI, Search for Extraterrestrial Intelligence. I love the idea that there could be an intelligent civilization out there that wants to send us a signal.
Mhm.
So I hope it will. I guess there's a lot of piggyback listening in that can go on using that. I hope it'll get to something. One thing is that, what's funny is, I don't know, I could ask you, both of you, or three of you, like, would you send a signal? Like, how do you feel about if here we created a signal and we wanted to beam it out with as much power as we could to all the planets nearby? Like,
Yeah, it's interesting.
it's
I had an elementary teacher, and I don't know why this always stuck with me, but we were discussing aliens, and I want to say I was probably in 5th grade, and she said that she believed that there was other life out there, but she thought that they were either far too evolved and far too intelligent to care about us, or far too primitive to ever send a signal. And I don't know why that always stuck with me, but I feel like that is sort of, I share a similar feeling.
I like that idea a lot. We're just mismatched.
Right.
In the case of sending a message out, people always revive this idea once in a while. And we have sent a message in the past, but they don't like it because they worry that what if they are far more capable?
Right.
And evil, So I think there's a lot of feelings, but I really like that. I'm going to take that one with me. And
yeah, no, please do. It stuck with me for a long time. Well, those were my questions. I can toss it back to you, George.
Yeah, Ashley, do you have anything, thoughts on whether you'd send a signal or not?
I don't know. I feel like I'd be too afraid just in case. But it could be great. It's one of those you just don't really know.
Yeah, the sci-fi always portrays the alien coming to gobble up our planet. My favorite of all time, of course, is The Day the Earth Stood Still. Do you know that film, Sarah?
I don't.
The Day the Earth Stood Still.
I haven't seen it, but I know of it.
Yeah, it's certainly dated 1953. It's all Cold War, but the aliens come here to kind of give us a talking to about our behavior as a potential galactic civilization, that we should definitely get our house in order before we go further. And I just love that. That was a great ending of that movie, and that stuck with me as a kid. But
and we still need that message today, even more so probably.
Oh, we sure do. Yeah, we need a wake-up call like that. I'd love to see it happen. But barring that, I think sending it out, I think if they are, of a certain level of intelligence far beyond us, that they would be looking at us as like we might look at pets, and that way they would not be so out to get us. And the distances, maybe they could cross those distances, but maybe it's just so far away that even they can't traverse the distances to come here and really have a physical presence. There's a lot of areas that you touched upon today that are, like you said, before in the past it was, we can't touch that because that's kind of career limiting. But today, I mean, we knock down those barriers. It's sort of like what we're trying to do with education, with open. We're trying to knock down the barriers and open things up a little bit and do things slightly differently, to get that creativity out of the students and open their minds that, they can be inspired to do a lot of different things. And that's what I want to thank you for your time today, for, really passing along that message to our audience of students and teachers around the world. But I think it's multi-generational what you're doing. And I always want to put forth that message too, because cleaning up the earth and doing all the things that we need to do for this planet is multi-generational. Mm-hmm. And we have to start thinking a lot more like the Aboriginal societies of this world who thought to the ancestors and thought forward to future generations and leaving it intact or in at least as good a shape for what's coming down the line. And, just throwing out that baton to the kids that you're doing, and that Starshot and others, maybe some stuff that's going to be on the moon with radio telescopes on the other side. This is mind-blowing, and things we dreamt of in my childhood. And now I'm lived long enough to see it happen. So kudos to you, and keep pushing the boundaries, and I know you will. And I would love to check back with you maybe in a year or two, and then see what has unfolded even. And this is a kind of a cool year with all the things that are going on. And I want to see, further on work on the Phosphine and something close by, as well as the far-flung exoplanets. So just one last question from me. When do you think we will know if there's other life out there?
Well, from today's interview, you know that's far from now.
Yeah.
I think we'll have signs of life.
Mm-hmm.
Not 100% confidence, but we could get that really anytime.
Right. But real confirmation it'd be a while.
Okay, so my personal hope is that there is life on Mars or life in the clouds of Venus. And sort of my dream, I'm sure others share it as well, that we can bring samples back from those planets. I mean, NASA is planning to bring a sample back from Mars. We have ideas. We and others have ideas about sample return from Venus. I do kind of feel that we do need some really hard evidence like that for people to believe it.
Yeah. And being such close proximity as those two planets, one's next door to us, then that makes it a little bit easier on our end. And that really, if life could evolve in those two places and still be clinging there, that bodes well for life in that we could find on exoplanets.
It sure does.
Yeah. Well, thank you again, Professor Seager. Really appreciate
Thank
your
you.
time and your insights. It was very mind-opening for me, as always. Thank you.
Great talking to all of you.
Take care.
Thank
Have
you
a
so
good
much.
weekend. Bye, everybody. Thank you.
Bye.